Okay, so these videos are building upon each other. First, we created a single node cluster. Then we created a multi-node cluster with a one control plane node and 3 worker nodes. This time we're going to create a multi-node cluster with a load balancer out front, 3 control plane nodes, and 3 worker nodes. The nodes have already been initialized with the setup node script that you've seen previously. So we'll go ahead and get started here, first by configuring the load balancer. So this is in the Git repo, and it's a script that does everything. First, we'll just go ahead and run that script, and we'll talk about it later what it actually does. And I have run this before, so the output might not be perfect, but here we go. All right, so we should be able to do a systemctl status haproxy. All right, and it shows that the app is currently down. Well, not this app, but this app here with our demo control plane nodes. So we're going to watch this file just for fun. Actually, in that haproxy config. It's watching this other app. Let's go ahead and clean that out just to make the output a little more clean. Okay, so in any case, the load balancer is set up, but it's not really doing anything, right? Because there's nothing here, because we haven't done the initialization yet. So let's go ahead and do that first initialization. And that's very similar to what we did before. We're just going to change the endpoint. So just like before, we're going to copy this over to the first control plane node. We're going to change that endpoint to be demo in this case. So this is the load balancer at 10.0.10.1. Oops, typo. All right. So we've got our endpoint, and now it's exactly the same as before. We're going to perform our initialization, wait for 40 seconds after stopping a couple of phases, skipping a couple of phases, wait for 40 seconds, then redo the skipped phases. Yeah. This is all just on the first control plane. And I will pause the video and pick up after this step finishes. All right, initialization is completed. And now we have our commands to run to add control plane nodes and commands to run to add the worker nodes. We're going to add these one at a time. Here's the second control plane node. Here's the third control plane node. Now I have seen these fail before, although it's kind of rare. You can run a kubeadm reset command and then just try again if it does timeout for some reason. Still waiting for these control plane nodes to show up in the reverse proxy. That's okay. In the meantime, let's go ahead and we're going to add the worker nodes next. Is this one done? Yep, third control plane node is done. Let's add a worker node. We're doing these one at a time because I read at some point that you don't want to do them all at once. So just to be on the safe side, one at a time. But I'm betting it started to become pretty obvious at this point that this is kind of a lot of work, right? Isn't there a way to just do this more easily with something like Terraform or Sedero and Talus or Cluster API or VMware Tanzu? Yeah, I think there's like 100 different ways to deploy clusters out there. So that's for another video. We're just doing it manual now, just to learn, and maybe just to get a little experienced with it to the point that we don't want to have to do it anymore. But it's still good to give it a go. All right, so our control plane should be fully initialized with 3 control plane nodes, and the worker nodes, 1, 2, 3, should all be good to go as well. Let's see if the demo can see them yet. Maybe there's a step we're missing. Let's just do some testing real quick. Do we have telnet? Nope. I know there's lots of ways to test if there's a port open. This one should be fine though. Here, all right, let's use a curl. Why not? No, curl with a colon. All right, so at least it's showing that it's listening, right? Maybe we can make it a little better. All right, insecure test 6443. So it looks like it's working even though it's not getting access. So first worker node is good. Let's try it with the second one. Yeah, it looks good too. So all 3 should be listening now on the 6443. So why aren't you seeing it yet? haproxy. Let's see what happens if we connect to the proxy. So by connecting to kdemo on 6443, it should redirect to one of the control plane nodes. Oh, I think it might be working, even though this isn't showing that it's working. Okay, so I just wasn't watching it well with my watch command. The lines were down here showing that the 3 are up. So we should be good to go at this point. Now we just want to, well, pick up on the steps that we were doing before. Right, so we want to run, because we're going to use Calico to install our CNI, just like before, we need to run these commands about the network manager on all the nodes. So let's go ahead and take care of that real quick. So yeah, the steps now are all just like in the last video, but just for completion steps, let's go ahead and make it work. Nope, do that as root. So as mentioned before, I have a script to merge all my kube configs together, and I went ahead and renamed a little bit within that admin configuration file to make it unique amongst the other kube configs. And I added in, or I used k-demo instead of Kubernetes. So now we can go ahead and merge them together. Should be able to switch over now and get our nodes, which will not be ready just yet. All right, things are looking good. So this just connected to the load balancer up front in front of the 3 control plane nodes, and it's rotating between the 3. And everything is working good. So let's go ahead and continue on. We already have Helm installed on my machine. I've already updated the Helm repo from Project Calico. Let's go ahead and install it. This installs the CNI that will bring it from a not ready state to a ready state. And we can watch that happen. Let's go ahead and grab the next command. So we already added the Helm repo again to my own machine, and we've got a couple configuration files there. First, we have to install Helm, and then we'll run those configuration files. And this has to be ready before we install the metal LB, otherwise the metal LB pods will not start. We could run the command right now, and it won't work until they're ready, but it'll start working. It'll keep retrying until it finds a ready node. So now we'll go watch this one start up. All right, so and we've got some additional speakers. You might notice this from when you saw it last. It's because there's more nodes. So things are starting to become in a running state, but they're not ready yet. Once they're ready, we should be good to go. All right, so we are done. Oh. Well, let's run something just to take a look. So WordPress is starting up right away in our brand new cluster. And all right, here we go. Right now it has no external IP, but we did configure a range with metal LB, so let's just edit. Let's see. We don't have a service for it yet. Well, we do have a service. Let's edit the service. See if we can make that change with from a cluster IP to load balancer. It's going to let us do it. Did I misspell it? I did. All right, pending the external IP. You can do it. Well, hopefully you can do it. We're going to step away for just a second and take a look at that load balancer setup script. All right, so I did make a little script just for myself, and it has a couple exports here. This isn't real production stuff, but yeah, we've got our name demo. We've got our subnet that we're going to use with our control plane nodes. So this is all about the load balancer node. So I'm just turning off SE Linux by default, home environment. I'm installing the haproxy. That's going to be our load balancer. And usually I just turn the firewall off, but in this case I went ahead and configured the ports we're actually using by the load balancer. And the load balancer is only using 6443. But the load balancer is also using this IP forward to forward the packets along. As it says here, only if it's also acting as a gateway. So I'm just going to skip over this one and that whole conversation because, yeah, we'll just skip past that conversation for later. So we need this route command. So I'm installing NetTools for that. I'm just going to skip over this route stuff, but here we are defining a route. So this is using, now we're going to skip over that. This isn't going to be a video documenting route. But the thing is, right, you have this load balancer machine, and then you have all the machines behind it, the control plane nodes, the worker nodes. And the question is, do we go through the worker node, not just for 6443, but for all networking communication? Essentially, you can have a private network with as many nodes behind it as you want that you can't see on the network otherwise. The only way you can get to them through the network is by routing to them. Or, more likely in a home and lab network, even if you have a subnet there, it can talk to everything. So we have a couple scenarios there. We're just going to dodge around that. I'm going to assume you can talk to everything directly. But if you can't, if you do have a private network, this is the configuration for that. And as you can see, even though in my network everything can talk to everything, we're configuring it as if it's a private network. And that's fine for this demo. And here we are with an initial configuration with the haproxy. So I found that this command needed to be commented out. So there it is. And then here we're actually appending to the haproxy this configuration. And we're doing it a little bit dynamically using the values from a4. So we're binding to this load balancer machine with 10.0.10, which is up here, 10.0.10. And then Kate's name here refers to demo. So k-demo C1, k-demo C2, k-demo C3. And the script works for me because I always use this same name or IP convention that we're showing just below this window on the left. All right, and then we enable the haproxy and then start it up. And that's it. Oh, we still need to run those. Oh, that's the problem. I was over here trying to see, give us that external IP and waiting on it, but we never did run these metal LB commands. So let's go ahead and run those, and that'll configure. Let's see, did I copy that over? So let's link over to the deploy, single cluster node, metal LB, and then we'll run those. We'll apply those metal LB configurations, which should cause this to start working. And boom, it immediately got its external IP. All right, now we have a load balancer set up. And I just want to say one thing. You probably do want to be using this setup because if you have a power outage, there's a really good chance your cluster is going to go down. And what I mean by down is it just will stop working if you have one control plane node. And I've experienced this a few times because I have power issues where my home lab is. Now, the thing to do when that happens is I would recommend figuring it out, right? And just going through it. So it will probably be that etcd has issues. Now, I went through this myself. It took me about a week to dig into etcd, enough to figure it out and to bring the cluster back up. But the thing is, if you have 3 control plane nodes, I'm told the odds of that sort of issue, even when dealing with a sudden power outage, I'm told it's essentially 0. I mean, it can't be 0, but I'm told that's the case, that there'll just be a little bit of a delay, and then between the control plane nodes, they'll figure it out. And so far, that's been my experience. I've had a few more power outages since then. I'm not recommending you deal with power outages. I would recommend using a project called, there's one called Nuts, and it's related to using a power supply, like an APC power supply, and you can use that project and integrate with the power supply units to first shut down your VMs and then shut down your storage servers, right? So you can do it in a really orchestrated way. Do that instead. But there is a benefit, right, to having the control plane nodes for high availability. And now you've got that going. Good luck. Thank you.